All right, so I'm Don McCaskill, co-founder, CEO, and chief geek at SmugMug, a popular photo sharing company. Before we get going, I'd love to see who I'm talking to. So if you are at or about to start a startup, would you mind putting your hands up? So I just, okay. And how many people here would consider themselves to be technical? Okay, and how many are more sort of on the business side of things? Okay, about half and half. Great. Okay, so I'm gonna rip through these slides a little faster than I otherwise might, because the last couple of sessions I went to, there were great Q&A sessions, and I'd love to take questions from you guys. So let's get going. Okay, so who are we? Who's SmugMug? We are a set of superheroes. This is a photo taken about 6 years ago, 2006, when we first got introduced to Amazon Web Services. We now have more than 100 employees, more than 120, and so it's gotten a whole lot bigger, but we're all still heroes. So we're a premium photo and video sharing service. Everybody pays. We ask for a credit card right up front, so there's no free accounts. And we have millions of paying customers, and we store billions of photos. We are completely bootstrapped, so we didn't do any venture rounds or take any outside capital. In fact, we didn't take any inside capital either. We took 3 servers from a failed .com that we had, begged and borrowed and stole some data center space, and threw some software up and started asking for credit cards. Since we're a private company, we don't talk about our revenue numbers very often. The last time we did was in 2007 when we crossed 10 million. We are profitable and have been pretty much the entire 10 years. In terms of traffic, we get 35 million people a month, and we are a top 250 website in the US, so fairly big scale. Our challenge is sort of interesting in our space in that we are a premium service. People are actually paying us money, and so they demand more stuff, they demand it to be better, and of course faster. So we provide unlimited storage, we provide unlimited bandwidth, and the photos are huge. We store billions of them, and they are up to 100 megapixels a piece. And we do huge videos, 1080p at very high bit rates and everything below it. And of course, people are browsing on very high resolution displays and retina display tablets and things like that. So we have to display lots of photos, and we have to do it really fast. Our architecture, early 2006, pre-Amazon, was we had multiple data centers. We were self-managed and self-installed hardware. We were actually building our own hardware because we couldn't find components from many of the major vendors that did what we wanted them to do. So we had tons of spinning disks as people were uploading all these photos, and we had tons of custom servers we had to screw together and rack ourselves and de-rack when they broke, and pull broken hard disks out and all this sort of stuff. So we were spending a huge amount of effort on something that our customers, quite frankly, didn't care about. This is all distracting from our core mission, which is to provide a great place to store and share your memories. We weren't a data center company, but we were acting like one. So we got this fateful phone call in early 2006 out of the blue. I've asked around at Amazon to try to find out where the phone call originated from. Nobody's totally sure. The best bet we have is that Jeff Bezos put a bug in somebody's ear and they called us up. So the phone rings one day and they say, hey, this is Amazon. We know you think of us as a bookseller, but we'd like to sell you storage. And I said, okay, you guys probably have a lot of storage, so what are we talking about? And they said, how about 50 cents per gigabyte per month? And so right there on the phone, I got a sheet of paper out and did some quick math on what it was costing us, and we said, sorry, we do it for about 20 cents a gigabyte a month. And they said, really? How do you do that? And I explained how we were buying commodity off-the-shelf hard drives, OEM drives, and screwing them into storage enclosures ourselves, and all this sort of stuff. And they said, wow, that's very interesting. Thank you so much for the feedback. See you later. And weeks went by, and the phone rang again, and they said, we heard your feedback. How about 15 cents per gigabyte per month? Sold. I was in. So early 2006, we started playing around with S3. And we knew we needed lots and lots of storage. We didn't know if we were ready to trust this bookseller to actually store our photos. So our usage started off slow. S3 wasn't slow. We just started using it slow. So we decided that we would just make it be our backup in case of disaster recovery, and that we wouldn't sort of bet the farm on it, at least not at first. So we started implementing it as our backup data store. It took us less than a week. I started writing the code on Monday, and we were live and in production on a Friday, which was pretty awesome. And our first bill was a whopping $1,147.41. So we were pretty thrilled with the size of the bill. I spent a lot more money on hard disks that month, I can tell you that. It worked out so well and was so fast, durable, and reliable that we pretty quickly moved to it being primary and our on-premise storage being backup, and then we just got rid of the on-premise stuff. And we realized, wow, this is for real. So we had done some internal estimates on how much money we might save that first year. We were hoping that it might be around $500,000. After the year was over, we went back and did the math to find out exactly what happened. So we went from 64 million photos to 140 million photos over that time period. We stored 200 terabytes at S3, and those disks would have disk costs would have gone from $40K a month to $100K a month. So instead of spending $922,000, we only spent $230,000, and we saved $692,000 that first year in cold hard savings. One of the other things we didn't realize was, since we were shifting away from capital expense to variable op expense, there was a big benefit in terms of cash flow too. We no longer had to deal with depreciation and amortization and all that sort of stuff. So on top of the actual savings, there was some serious cash flow benefits too. And of course, as time went on, we got to sell all those disks we used to have and provision. And so about the same time, when we did the numbers, we realized that yes, this was cheap. We were saving money. It was awesome. It was fast. It was durable. It was reliable. But we realized that all of a sudden, the entire company, we were still pretty small, as you saw from that slide, got to focus on photo sharing. We got to focus on our mission instead of building machines and screwing in hard disks and midnight trips to the data center. In fact, one memorable time, one of our data centers sold our power allotment out from under us. They sold it to a bigger customer, Yahoo in this case, and just said, sorry, you're out of luck. And so we had to physically move all of our storage from one data center to another in the middle of the night one night. So what we did is we drove 3 of our station wagons over to the data center, old beater station wagons. The value of the hard disks far exceeded the value of the car, and filled them to the gills with hard disks. We planned 3 different routes through town so that there was no chance of a train or a car accident or something taking out all of our storage, and literally moved them all in one night. With S3, we didn't have to do this ever again, something I never wanted to do. My knuckles were white. I was sweating as I'm driving a third of our storage across town in the middle of the night. And so if there's one takeaway from this talk, for those of you, especially in startups, I want you to listen to, it's this, that you get to focus on what matters for your business, not on all this other stuff. So we had that revelation and said, well, what else can we do? Of course, it turned out that while this was sort of the dark ages for AWS, they just launched, they did have another offering, which was EC2, which so far we hadn't touched. So we knew we had lots of servers doing compute, and they had this thing called EC2, and apparently it was as good as S3. So we decided to sort of take the plunge. So we knew we had web server clusters, we knew we had background processing for photos, we had rendering stuff to do, all kinds of things, and we were buying lots of servers to handle this stuff and installing it ourselves and managing it ourselves and paying for all the power and cooling and everything. And of course, lots of this stuff was often idle. Our customers upload a ton of photos on Sunday evening after they've shot all weekend, but they don't upload that many, on a Tuesday or a Wednesday. And conversely, everybody views photos dramatically on Monday, when they get into work and they don't want to actually work. And then during the rest of the week, they're not viewing as much. So we had all these servers sitting idle that I had paid cold, hard cash for, and it's our cash, not some venture capitalist cash. So this was a big deal. So the low-hanging fruit seemed to be rendering. We render a lot of photos, and we render them to lots of different sizes, so we can support lots of different devices. So we built this thing, and it tried to take over the world. So we call it SkyNet, because it did try to take over the world. But its first name was Rubber Band. Ideally, it was going to be an elastic service that took customer uploads and turned them into web-viewable photos. Since it was elastic, it was going to be called Rubber Band, and it worked great. We were able to scale up and scale down. Sunday nights were no longer a problem. They used to take our site offline sometimes, all that sort of stuff. And I automated it so that there was basically no humans watching it. So it ran health checks across the cluster and got CPU loads and all that sort of stuff, and made its own decisions for when to scale up and scale down. Of course, I failed to put in some safeguards, and one evening it tried to take over the world by launching almost 2,000 cores in a single API call. Amazon Web Services said, yep, no problem, here you go, here's all your machines, BAM! Tons and tons and tons of machines. Luckily, I did catch it within the first hour, so I only paid an hour of usage. So we quickly renamed the service to SkyNet, and I quickly put in some safeguards. But fundamentally, SkyNet is still running, and nobody at SmugMug pays much attention to it. It just does its thing, and it turned out to be a huge win. We're able to scale up and scale down as needed, and our customers get their photos typically within seconds after they upload. So they can upload huge, huge batches, and we just farm them out across all kinds of different EC2 instances across availability zones, and away they go. So pretty awesome. It turned out to be very successful in part because we couldn't predict that user-generated load peaks, right? We could do some rough calculations. Sure, Sundays are heavy, but we don't know exactly how heavy they'll be. Was there some major sporting event that a lot of people were at that Sunday? And we knew, we could detect sometimes that big spikes were coming, but we didn't know how big. So it was at best roughly predictable, which is something we'll get to, you'll see on some of the other services in a few slides that we migrated to Amazon as well. We kept instrumenting and kept automating, and many of our services, including SkyNet, just have no humans operating them today. And then it dawned on us, too, this was months after we had launched SkyNet and stopped it from taking over the world and everything, that we might be able to leverage one of the other properties of AWS, which is we could provision a ton of stuff for a short period of time and sort of see how it goes. So it made it so that for the first time in our company's history, we could experiment with new products that we didn't totally know whether they'd be worth the investment. So customers were begging us for a video. We were basically just a photo sharing site at this point. And so we said, sure, yeah, we can do web quality video. And our customers, when we talked to them about it, said, no, we want high-def video. And not just high-def video, we want bit rates that I'd be proud to stream to my TV, not to some mobile device or something where it's all blocky and chunky. So they have pretty demanding requirements, and that would require racks and racks and racks of high-powered servers if we were to do it in our own data center, and we just weren't sure that there was a market here. There were services like YouTube out there and stuff that were really taking the world by storm, and we just didn't know where our little company would fit. So in the end, we just didn't know whether it would be a good product for our customers or not, but we knew that it would be relatively easy to write the software for, and thanks to AWS, we could try it out. So we just spun up a big cluster on EC2, rolled out our software, announced it to our customers, and sat back to watch. We knew that if usage went way up, that we'd just continue to scale, and we knew that if customers said, oh, actually, we know we asked you for this, but we don't really want it, that we could literally turn it off. We could just shut it down, and all we'd be out is the hours that it ran. So it worked like a charm. Our customers got to use it. The rendering was fast, all that sort of stuff. And it required a relatively minimal investment, mostly just software engineering time. And luckily for us, it took off. Our customers love our video offering. So midway through 2008, our customers were begging us for something else that, once again, we didn't know whether there would be big adoption or not, and whether it would be important and how expensive it might be. And that was for archival type storage. So we had offered unlimited storage, as I mentioned before, for sort of web formats, JPEG, GIF, PNG, and now MPEG-4. But our customers were shooting in RAW, they were editing in PSDs, Photoshop files, they were shooting with Hollywood-grade high-def cameras that were much bigger bit rates even than we were supporting, and things like this, and they wanted some place to store them. And ideally, they wanted to store them alongside the versions that people were watching. So totally breaks our business model, because we're providing unlimited storage knowing that JPEGs can only be a certain size instead of these whoppers that are coming off of people's cameras in RAW and things like that. And maybe costly to implement, lots of hard disks or whatever. Even S3, like we could quickly consume a huge amount of storage on S3, so S3 alone wasn't a good enough solution. And of course, we didn't know how many customers might actually be interested in this. So we decided to try it with the help of another set of AWS services. So it's called DevPay, and basically it lets you mash up S3 and Amazon payments so that any storage used actually gets billed to the customer rather than to us. So we enabled this for our customers to be able to simply turn on their account, and then they tie their SmugMug and Amazon accounts together, and they upload to their heart's content. Any type of file, any size, we don't even care. It can be Word docs, PDFs, whatever. So there were professional wedding photographers out shooting a wedding, and they'd upload like the PDF of the quote to SmugVault, as we called it, to be able to reference a year later or something, so they knew it was safe and sound and tied to the photos in question and all this sort of stuff. And it worked out great. We had happy customers. They immediately started storing terabytes worth of raw photos and raw archival video footage and all that sort of stuff. And we didn't have to handle any of the billing muck and all that sort of stuff. So pretty great. So there have been other cases where we have been able to leverage AWS to figure out whether a product makes sense. Sometimes it doesn't. I just talked about 2 success stories, but there's certainly the other way around too, which has come in handy as well. So by 2009, we had been informed by Amazon that they had this great new payments platform, and we could easily drop it in and see if our customers would rather pay for SmugMug using their Amazon credentials rather than trust us with their credit card. We're a small company, and plenty of people, of course, are worried about where their credit card details go. So we said, sure, we'll try it. It wasn't too difficult to implement, so we enabled it for our subscriptions. And immediately we saw a 7% uptick in the number of subscribers. So there was clearly, for years, probably, we'll never know for sure, but probably for years we were turning customers away simply because they were willing to pay, they just weren't willing to trust us with their credit card data. So that was pretty fascinating. And then finally, EC2 really started to get going for us. Up until 2009, EC2 was mostly just compute instances. And there was all this additional infrastructure that we needed to move some of our richer services over there. We needed load balancing. We had written our own auto-scaling stuff for SkyNet, but it was very specialized. It wouldn't work as well for a general purpose thing like a web cluster or something. There was no monitoring, so we were doing all of that manually too. But in 2009, Amazon heard our pleas, and presumably hundreds or thousands of other customers' pleas, and started releasing all these extra services and tools that really leveled EC2 up. And so we got to start peeling off more and more services that were running in our data centers and gradually migrating them to AWS, which was a huge win. So the first one we tackled in 2009 was our photo and video serving platform. So we had already been rendering, as you remember, in the cloud, but until now we were still serving them from our own data centers and our own web clusters. And one of the biggest reasons we were doing that is that SmugMug has a very complex and detailed security and privacy layer that doesn't map well to the way S3 handles, public versus private versus ACLs. And so to move stuff up to Amazon to enable us to serve the photos and videos straight from Amazon, which would be ideal since it's close to S3, also required us to figure out how to handle that security and privacy layer in the cloud too. And it would have been possible but very difficult to do before the advent of the elastic load balancing and all that sort of stuff. But now that we had those things, we moved it, and now client requests for all the photos and videos were coming straight from Amazon instead of doing this circuitous route behind the scenes from Amazon to SmugMug and out to the client. So that turned out to be a big win, and we got to blend in auto-scaling and ELB and EC2 and S3 into this very mission-critical service for us. The next one in 2010 was our real-time rendering service. So we have a rich public API and thousands of API developers, and both internally at SmugMug and many of those external developers often have very precise resolution requirements when they want to display some photos. You can imagine on all the different mobile phones that everybody in this room has, you guys all have very different screen resolutions, and ideally we want to serve exactly the right pixels for your screen, both because it looks better and because it can consume less bandwidth. So for quite some time, we've allowed developers to basically specify the width and height in the URL for all the photos that are requested from SmugMug, and we'll just render them specifically on our backend to that resolution. Obviously, now that we're serving the non-real-time rendered photos at EC2 at this point, it makes sense to move this service up to EC2 as well and get rid of that sort of circle round trip. Again, this is one of those things that's unpredictable from a user point of view. One of the biggest consumers of this, especially back then, was our full-screen slideshow app, and so we didn't know how many people would find a set of photos and hit full screen and need dozens or hundreds of photos rendered at very high resolution, very rapidly to a specific pixel dimension, and so we had to make sure that we understood auto-scaling well, and stick this behind yet another ELB, and in fact we had to tie the previous service and this one together so that they could talk to each other in case there was some overlap. So this was even more complicated, but it was an awful lot of fun and resulted in even faster serving of photos, especially to mobile devices and unusual screen sizes. Probably the most recent public customer-facing one during this time period, we're busy moving all kinds of other behind-the-scenes stuff to Amazon, but uploading was a huge one. So up until this time, up until 2011, we were still uploading into our data centers and then copying across country to S3. And there were all kinds of reasons for this, but the biggest is that it's one of our most complicated services. There's all kinds of issues around format verification and access controls in SmugMug's security settings and everything that sort of resulted in a much tighter integration with our core web service, and so it took a lot more effort to break this out and move it up to the cloud. But it was a big win, as you can imagine. It's a lot more efficient for customers to go right to where the storage is, because we can store it quicker, more reliably, and we can get SkyNet working and on processing the photo that much faster. We couldn't use auto-scaling in this case, because auto-scaling still to this day terminates instances with just a grace period that's like 1 to 5 minutes or something like that. And as you can imagine, a long-running video upload getting terminated just because auto-scaling had decided we needed less instances behind the scenes wouldn't be so great for our customers. So that's something that we are handling internally ourselves. We're hoping that auto-scaling continues to improve, and we can improve along with them. And once again, this is completely unpredictable load. We see customers sign up for the service and migrate their entire life's worth of photos, tens and even hundreds of thousands of photos, in a single sort of uploading session once they sign up. And often those people are at campuses like Microsoft or Google, where they have huge bandwidths. I can only imagine that they've carried their hard disks in and plugged them into their work computers and they're uploading them. And we needed to be able to scale to handle those sorts of loads. You can imagine we saw a lot of extra uploads during big sporting events and natural disasters like hurricanes and things like that. And so pretty unpredictable. We had to handle scaling ourselves, but it was turned out to be a lot of fun. So today, the vast majority of SmugMug CPU usage is in EC2. We still have a small amount in our data centers, but 100% of the photo and video requests are served from AWS. And 4 out of 5 of our major large customer-facing web clusters are in AWS 100%. The final one on that stack is in private testing right now in AWS, and we are hoping to be able to turn it on pretty soon, which would result in SmugMug, the entire stack, finally being 100% in AWS, which is something we have been waiting for 6 years. As we grew, along with AWS, we continued to have higher and higher demands on our system, and so we were continually outpacing particularly the I/O capabilities in EC2. So ephemeral disks and EBS, we just weren't able to get the performance we needed out of them, and so we were sort of waiting for some magic sauce, which finally arrived this year in the form of DynamoDB and EC2 instances with SSDs. In our data centers, all of our database machines have been 100% SSD for quite some time, and there's no way we could have sort of weaned ourselves off of our addiction to SSD to go into the cloud. So the fact that they are there means that we finally have 100% AWS within our reach, which is pretty exciting. We've been, like I said, working on that for almost 6.5 years. So if you haven't heard, the SSD instances are pretty amazing. I'm so excited about them. I have a whole slide just on those. They are extremely high-scale IOPS systems. We are going to use them primarily for databases, but there are a few other use cases we're thinking about as well. It's one of the 2 final missing links to let us migrate 100% to AWS. And each instance has 2 terabytes of SSD storage, which are capable of 120,000 random read IOPS at extremely low latencies, typically like sub 1 millisecond, and 10,000 to 85,000 random write IOPS, depending on how the writes are distributed across your disk and stuff. So yeah, they're pretty amazing. The other unbelievably amazing thing for us is DynamoDB. So this is the other thing that was blocking us from moving, and it's much like S3 for databases in that it's totally bottomless. It's replicated for you across multiple AZs. It's insanely performant, and in theory, we can just throw as much data and as much workload on it as we want, and it will just do its thing. So it is a key value store. It's not relational, like a typical SQL store is, but that's okay because long ago we had discovered that key value storage was one of the important keys to our scaling success. So the vast majority of SmugMug's data is already key value store. It's just in SSD-backed MySQL instances instead of DynamoDB. So we are busy moving tens of terabytes to DynamoDB over the next few months and are pretty excited to have it live there rather than in our systems where we have to monitor and maintain them. There was another awesome piece of alien technology that came out this year called CloudSearch. So this wasn't exactly a blocker for us moving into AWS, but it was something that had gotten to be very, very difficult for us. So this is what a search for beach looks like on SmugMug today, with CloudSearch backing it and our UI fronting it. You can see down the list that there is a long list of different things you can sort and search by. We have tons and tons of facets on our data, and the data is very large. We have billions of documents to search. We have rich metadata about every photo in our system, and the quality varies, but some of them have close to 100 different pieces of data we might want to search and sort on. And so over time, our internal search infrastructure had basically become duct tape and SSDs. We had just jammed hardware behind it as fast as we could just to keep up with demand, but to do so, we'd been cutting features, and our search had quite frankly, gotten to be subpar, which is pretty critical for us. So with CloudSearch, we were able to jam those billions of documents. It takes a while to transfer billions of documents, but we were able to jam them all into CloudSearch and just say, hey, just handle this for us, please. We're done with the duct tape and buying the SSDs and all this sort of stuff. So it is crazy fast. Even with crazy queries, you can search and sort by camera, make a model and lenses and resolution and whether it's for sale and what price range it's for sale and all these things that we weren't ever able to do even when our internal search engine was working properly. So pretty amazing, big win for us. So this is I'm sure there might be more questions during the Q&A section, but I always get lots of questions about handling failure. So I thought I'd cover some of it really quickly. Everything breaks. We, like I said at the very beginning, in 2002, we used 3 old and busted servers from a failed .com to get this company off the ground, and we knew those things were on their last legs already. So, and I'd done internet companies before, so we knew in our bones that everything breaks. So luckily for us, this was in our DNA before AWS came along, because we'd seen it break in our own data centers. Over and over and over, stuff breaks. So we've built SmugMug and its various services and components with failure in mind. Failure is, right now, something is broken on SmugMug. I don't know what it is, but something, I promise you, is broken right this second. And so we just plan for it. So one of the nice things about AWS, unlike my own data centers, we still have 3 of them, where that's a low for us, and hopefully we'll be at 0 soon, is that when AWS breaks, it's mostly clearly defined. You know what services, what machine instances, what availability zones and what regions are and how they work with each other. So you know that DynamoDB spans multiple availability zones, for example, but you know CloudSearch does not, at least not yet. So you can plan for stuff because you have this concrete data about how failure happens inside of AWS. The kind of concrete data I didn't have in my own data center. We didn't know if we would have rack level failures because of failed power strips or failed switches, for example. And you can mix and match it to your heart's content. If your data or service is critical enough that it needs to be multi-region, and you have the revenue stream to back it, then it's pretty easy to do. If you're not, then you can do multiple availability zones. If you're just getting started, you're a brand new bootstrapped startup, you might not need multiple availability zones. You just spin it up in one AZ and go to town. So you mix and match for your needs. For us, right now, multiple availability zones is our sweet spot. So most of our stuff is running in at least 3 and often 4 availability zones. And so we've survived most of the Amazon apocalypses, what Amazon describes as a service event. So they do happen. They're not going to stop happening. AWS does a much better job at handling these failures than we do, so the failure rate has been dramatically lower over the last 6 years in their data centers than it has been in ours. So as disappointing as it is when one happens, A, we've built for it properly, and B, we know from cold, hard-earned experience that we would have them ourselves too. So it's not the end of the world. So that is all the slides I had.